Okay, we're back. Still with the trains. And we have a new situation. We have a train leaves Bridgeton heading east, going towards the city. So let's say this is Bridgeton, and this guy heads this way, going 90 miles per hour. And this guy's at Cogsville. These are just made up names. He's going this way at 450. Nope, at 100 miles per hour. That would be really fast. And then the question is, what time do they meet? Basically, what time do they pass each other? It's like, what time do they get to the middle? Oh, it might not be the middle. It's probably not going to be the middle, actually. But this guy travels this way, and this guy goes this way. And like, I want to know, what time does this happen? This is like not an unrealistic problem. I might want to know the answer to this question if I'm like an engineer or something. So we can probably do the distance equals rate times time table again for this. Draw me a little table, 2 rows, 3 columns, distance equals rate times time. So I'll call this one the Bridgeton to Cogsville train. I'll call this one the Cogsville to Bridgeton train. So it's like train 1 and train 2. Pretty standard for the Bridgeton to Cogsville train. I don't know the distance yet. I do know the rate. This one is going at 90 miles per hour, and I don't know the time. And I don't know the distance for this one. I do know the rate, it's 100, and I also don't know the time. So when I don't know either of these things, I know I'm probably going to make one of them D and one of them T, and then figure out the other ones based on that. So I'm going to go ahead and make this one D and this one T, and then see if I can figure out what to do with the other two. So this guy travels some distance, some portion of this is 450 miles total. I probably should have written that up here. The distance, the total distance here is 450 miles. This guy travels some portion of the 450 miles, and then this guy travels the rest of it. So very similarly to the last problem, if this guy goes D miles, this guy goes the rest of them, because we want to know when they're at the same place. So that's going to be D minus 450. Nope, that's backwards. 450 minus D. That makes more sense. 450 minus D. And now the times are a little tricky on this one because of this 12:15 part. We got 12:15 and we got noon. Oops. So I feel like we saw this in a different problem once. Noon. Like, how much more time is 12:15? Like, how much? So this guy travels, the one that left earlier travels for more time. The one that left later travels for less time. So this is going to be T minus something. What goes here, though? And it's tempting to say 15. But that's not going to work because the time is being measured in hours. I know that because these rates are in miles per hour, not miles per minute. So unless I want to change these to miles per minute, I can't use the 15 as the piece of time that this one traveled for less. So I got to figure out this question. How many hours? I don't know why I wrote a Y there. How many hours is 15 minutes? I can't remember which problem it was that we saw this in, but we saw that, like, because 15 minutes is less than an hour, this is going to be some fraction of an hour. And it's 15 minutes over 60 minutes. Tells me that's 1/4 of an hour. So if this said like 12:20, I would have done 20 over 60 to get the fraction of an hour. If this had said 45, I would have done 45 over 60 to get the fraction of an hour. If this had said 52 over 12:52, I would have said 52 over 60, the fraction of an hour. But whatever it is, it's always over 60. This time it's 1/4. So the difference between the two times is 1/4. And like, what I think might be tricky is to remember that you're not going to add it to this bottom one, because this train, since it left 15 minutes later or a quarter of an hour later, traveled for a quarter of an hour less time than this train. But this setup should work. I got the right distances, I got the right times, I got the right speeds. So I get D equals 90t. I wrote a 9, which is wrong. D equals 90t, and 450 minus D equals 100 times t minus 1/4. And now I think I can do the same trick I did in the last one because I have a positive D and a negative D over here already. I can just add these two equations together. D plus 450 minus D, the D's cancel out. I get 450 equals 90t plus this mess, 100 times t minus 1/4. And now we just got to get the t's by themselves. So maybe multiply the 100 into the here, like distribute the 100. 450 equals 90t plus 100t minus 25. 100 times a fourth is 25. Now I move the 25 over here, so I get 475 equals 190t. I'm doing a little division. I get, let's see, 475 divided by 190 is 2.5. T is 2.5 hours. But again, this time, if you read the question that's being asked, at what time? It doesn't say how long after they leave. It says at what time. So let's remember the T, which is what I solved for, is the amount of time that the Bridgeton to Cogsville train traveled for. So since it's 2.5 hours, it means that this train, the Bridgeton to Cogsville train, traveled for 2.5 hours. And that train left at noon. At noon, a train leaves Bridgeton heading east to Cogsville. So this train traveled for 2.5 hours, leaving at noon. 2.5 hours after noon is 2:30 p.m. The trains will pass each other at 2:30 p.m. So that's how you do this problem. And this one involved kind of two tricks. One we saw before, where if one distance is D and you know the total, you can write the other one as 450 minus D, whatever the total is minus D. And we saw this, maybe two tricks here. This was kind of a similar one before, but the trick here with the 1/4 was to remember that 15 minutes is not the same as 15 hours. If you hadn't written T minus 15 in here, it wouldn't have worked because it would assume that this train left 15 hours later. That'd be a much different answer. Actually, it wouldn't be an answer at all because this train would have already gotten there 15 hours later. So it's got to be a fourth. You got to pay attention to the minutes versus hours. Okay. All right. This is probably the last one we're going to do here. We can talk about this one in class, maybe the point of no return. Okay. This time we have some distance between two towns, B and G. I don't know what that distance is, but I'm just going to call it D. Some passenger train goes, it takes a trip at 60 miles per hour, and a freight train makes the trip at 40 miles per hour. These are not very fast trains. And the time it takes this guy to do it is 2 hours less time. So maybe I should call this one T. That'll probably make the numbers easier. So this one takes T hours, this one takes T minus 2. That's 2 hours less than the freight train. It makes sense this one should be smaller because it's going faster and they go the same distance. So two things that go the same distance at different speeds, the faster one takes less time. That's just simple common sense physics. So we can probably write I'll do the table again, though you wouldn't necessarily have to do it for this one if you kind of see what's happening. Two rows, 3 columns. D equals R times T. So I got the passenger, that was the one on top, right? Yeah, passenger train and the freight train. So I have everything kind of written in my picture here already. The rate for the passenger train is 60. Rate for the freight train is 40. The distances are the same. I don't know what they are. It doesn't tell me, but it doesn't really matter. I'm just going to call them both D because it's the same distance. And now the times, I actually wrote them over here. I wrote T minus 2 for this one and T for that one, because this one took 2 hours less to make the trip than this one did. Now I have to, if we just want to pay attention, how far, it says how far it is. How far is it? That's weird. How far is it from Brownsville to Greentown? So really what I'm trying to find is D at the end. And the answer should be in miles because my rates were in miles per hour. So D equals 60 times T minus 2. That's the top equation. And D equals 40 times T is the second equation. And really, I'd like to eliminate T, but it's going to be hard to do that first. So I'm just going to substitute. If D is 40T and D is 60 times this, then these things must be equal to each other. So that gives me 40T equals 60. I'm going to multiply this. 60 times T is 60T. 60 times negative 2 is negative 120. So I subtract 60 from both sides, negative 60T. Nope, that's wrong. 40T minus 60T is negative 20T. Let's try that again. Negative 20T is negative 120, which means T has got to be equal to 6, because negative 120 divided by 20 is 6. Negative 120 divided by negative 20 is 6. So 6 hours, which is great. But the question was not about how long does it take the trains to do it. The question is how far is it? So now I can just plug this T into either one of these equations. And because this one is an easier equation, I'm just going to plug it in there. So I combine this with this, and I get D equals 40 times 6, which is 240 miles. And I'm done. Notice I put a unit to indicate that I know that the 240 is a distance and not a time. So there's 4 slightly different kinds of these distance problems. Just for the sake of consistency, I did them all with a table. You don't necessarily have to do them all with tables, but I wanted you guys to have like a process, if that's something that makes you happy, to be able to, like, here's how I start these. I make a table and I start filling in things I know. That's kind of handy. And I'm happy to talk to you guys about other ways to do these in class. So hope this made sense and was helpful.